All right, do a few problems from section 6.3. All these problems are really similar to each other, so once you get the process down, you're not going to have any trouble. There's not a lot of variety in this section. So this one says, suppose the mean income of firms in the industry for a year is $95 million for the standard deviation of $11 million. If incomes for the industry are distributed normally, what is the probability that a randomly selected firm will earn less than $114 million? So it tells us that our data is distributed normally here. Okay, so that's important. That means we're going to use a z-value in this problem. And to come up with the z-value, it doesn't give it to us, so to come up with it, it's x minus mu divided by sigma. Okay? Mu is the mean of the data distribution, sigma is the standard deviation of the data distribution, and then x is the data value that it's asking us about. Okay, so to get our z-value here, we got $114 million, the one in the question, and then it says the mean of this distribution is $95 million, and the standard deviation is $11 million. And we're going to round this to 2 decimal places, so let's see what we get. 114 minus 95 equals 19 divided by 11. When we round to 2 decimal places, it's 1.727, so 1.73. And that is our z-value. And then we want to know the probability of this. So that means we're going to look up area in the table. And since it says less than, that means we want the area to the left of our z-value. Right? Less than will be to the left. So we're going to go to our z-tables and we're going to look up the area to the left of 1.73. If you remember the last section, that means we just look up 1.73 in our tables. Okay, so I'm going to go over to Hogs. Okay, I think I am. There we go. And ignore the problem up here. This problem doesn't have anything to do with what we're doing, but we're just going to use the table. So we want to look up 1.73, so we'll do negative infinity to z. We're going to go to 1.7, this row, and then over to 0.03, so that'll be 1.73. So our probability, our area, is 0.9582. So we can write that down. So from the table, forgot what the number was, 0.9582. Okay, so we could say, if we change it to a percentage, we could say there's a 95.82% chance that a randomly selected firm would earn less than $114 million. So the only thing that really changes on these problems is this, right? What type of area we're looking for. So this one, we wanted area to the left. And we could have to the right or in between or two tails. So let's look at another problem. All right, so this one says the diameters of ball bearings are distributed normally, so we're going to use Z. It says the mean diameter is 74, so that's going to be our mu. And the standard deviation is 3 millimeters, so that's going to be sigma. And we want to find the probability of that the diameter of a selected bearing is greater than 71 millimeters, so that's going to be our x. So to get our z value, it's going to be x, 71, minus mu, 74, divided by sigma, which is 3. We're going to round it to 2 decimal places. So 71 minus 74, that equals negative 3 divided by 3. So we get negative 1, and since we're going 2 decimal places, we'll call it negative 1.00. Okay. Now, since it says we want the probability of this happening, we're going to look for an area in the table. Those areas represent probability. So we got to know what type of area we want. Do we want the area to the left, right, in between, or two tails? Well, this one says we want the probability that it's greater than 71 millimeters. So greater than, that's going to be to the right. Okay. So if we want the area to the right of negative 1.00, How do we find that? We're going to, one way we can do it is we can look up the opposite. So we can look up positive 1.00. If we want the area to the right, then we look up the opposite of whatever z we have. So we want positive 1.00, so we're going to go into positive z here, so we'll go down to 1 and 0.00, and our probability, our area is 0.8413. And so we get that right out of the table, 0.8413. From table, it's 0.8143. Let me double check that. 0.8413, that's right. Okay. That's our probability on this one. Okay. One more. They're, like I said, they're all really similar to each other, so the only thing that changes is the type of area you want. So this is as complicated as I get in this section. Since it says the weights of steers in a herd are distributed normally, anytime you see that, you know you're going to use a z somewhere. The variance is 40,000, so it threw us a little bit of a curve here. Variance is sigma squared. So on this problem, how are we going to get sigma? We got to take, if we want standard deviation, we got to take the square root of 40,000. So sigma is going to be 200. And the mean is 1,300 pounds. This time it says find the probability that the weight of a randomly selected steer is between 1620 and 1740. So here, instead of having one x, we want to know between two values, so we're going to have two x's. We can just call them x1 and x2. And so we're going to have to use our z formula twice here. We've got to come up with two z values. All right, so I'll call this one z number 1. We'll use x1, so 1620 minus the mean, which was 1,300, divided by the standard deviation. Remember, that's this one where we had to take the square root, so divided by 200. Okay. So if we do 1620 minus 1,300, gives us 320 divided by 200. We get 1.6. Since we're going two decimal places, we'll call it 1.60. That's 1z. Now we're going to find our other one, so we'll call it z2. So this time we'll use 1740. 1740 minus the mean of 1,300 divided by the standard deviation of 200. See what we get there. So 1740 minus 1,300 gives us 440 divided by 200 gives us 2.2, and making it two decimal places, that'll be 2.20. Okay. So now we want our probability to be between these two z values. So to find the area between two z's, we look them both up, and then we subtract the areas we find. Okay. So we'll go to our tables. We got 1.6 and 2.20 we got to look up. And so if we go to 1.6, let's see this right here. The table's a little off there. It's 0.9452. Okay. So 0.9452. And then we need to look up 2.20. So look up 2.20. It's going to be right here, 0.9861. Okay. So 0.9861. Then we need to subtract. Remember, our answer can't be negative here, so we got to put the bigger one first. 0.9861. And the reason why it can't be negative is you can't have a negative area or a negative probability. They have to be 0 or bigger. So the big one minus 0.9452. We subtract, so 0.9861 minus 0.9452. We get our final answer of 0.0409. And that is our probability here. That's one of all three types that are in the homework here. Don't worry about it being late if you're still working on it. Normally, you got a 24-hour grace period anyway, so as long as it's less than 24 hours late, you get all the points. But right now, from before, I still it'll count it late, but it's still not taking any points off. So don't worry about that. Okay. Let me know if you have any questions.